Bismillahirrahmanirrahim. So let's move to the next point. That was explain the client server and peer-to-peer models of network computers. Okay. So first of all, now we understood different types of arrangements that shows that makes you while sitting in Pakistan that makes you talk to somebody who is sitting in Brazil, who is sitting in Argentina or Portugal or anywhere who's sitting, okay, anywhere around the world, okay. Matlab, you are connected to your land, that land is connected to the man of the city, okay, of your province of your state, and then that man is connected to the overall WAN, the wide area network that we have, the internet that we have, okay. So at class when we'll be practicing, so we'll be more tailored to what the company's demands from us. Okay? So don't worry if you missed out something. Okay? We will recover later when we practice things. Okay? So now what is client server and peer-to-peer model of network? Now we have learned that in a LAN, computers are connected together. But how are they connected? Now this is that has two different types in it. Okay, so one is client server, one is peer-to-peer model. Okay, so for example, in your office, in your computer lab. Okay, so every computer may not, but your computer lab, whole computer lab is there, and then there are some computers that the students work on, and there may be some administrator there, there may be some uh, of the there may be some faculty member there that supervises all the students when they come for some computer class or something. Okay, so now that writes the abilities that faculty member will have that some students may not have. For example, you know uh, dealing with some uh, dealing with some changes to settings, okay, or making some other changes, or adding a new network of their own, or some such choices that the students may not have, but the faculty member may have, so that he can, so when some problem occurs, he can set up the problem, okay, or if some computer is not working, he just go to setting or make changes according to the students and their needs, okay. So that system, that faculty member may have more rights, and he may even be managing the rights of the computer. For example, if some teacher comes there, so he may have to just, there are some PCs that are dedicated for teachers. He may have to increase their rights, or like give them more rights about their settings and how they can control themselves. Because since students don't have so much, you know, rights to do to do things, or to make changes the settings, because they are they are not tailored, they are not dedicated for that. Okay, they just come there for some time, learn the things they want, and then they go. Okay, so how are those computer connected? Okay, so we will learn that. Now come here. Here we have, we just missed that. Okay, but let's do. Okay, that we'll do at last. Now, what is peer-to-peer and what is client server model? Okay, first we should see from here. First of all, you need to client switch. No, bro. It's actually client server model. You might have seen the syllabus, is it? Okay, client server model. And this what happens. All the computers are connected to some central server. Oh, look that. Okay, so all the computers, for example, in your computer lab, they may be connected to some central computer. If node 2, the computer 2 has to send a message to node 4, it cannot directly send it. Okay, it will have to first send it to the server, and then the server will decide the it will first send to the server and the actual administrator. Okay, and then that server will send it ahead to node 4. Okay, then node 4, if it was sent to node 4, it doesn't have a direct connection. Okay, but it will send to the server and then node 1. The best example that you can have is of WhatsApp. Okay, you see, when you send a message to your friend, for example, if you have a stable internet connection, okay, and you are able to send a message, so you see one tick there. Okay, uncolored tick. Okay, so then if he that your cousin, your friend where you're sending messages to, okay, the receiver. If he also has a stable internet connection, then you receive two uncolored texts. And when he sees the message, when he has when he has seen the message, so you see two blue ticks. Okay. So, but what happens if you send a message, but he doesn't have internet connection? He is not connected to the internet. He is not connected to you. So, what happens? You see one tick, okay? But when as soon as he gets connected, then you see two ticks. That means he has received the message, okay? So what happens? But for example, if you send the message and he didn't receive the message, so where did the message go? So that's what actually the perfect example of client server model is, that you send the message stays on the server and waits for the receiver to have a good internet connection and to have a connection to the server. As soon as the receiver has a connection to the server, that receiver receives the message. Okay, for example, I'm sitting in, you know, I am sitting in Riyadh, okay, and this node 2 is in Alaska. Okay, so if I want to send message from Riyadh to Alaska, so I send him a message. He's not connected to internet for now. He's cut away from the internet. But I send a message. The message stays on server. Okay, now server waits for the computer for my friend in Alaska to connect to the server. And as soon as he connects, the message goes to him. And as soon as the message goes, as soon as the server sends the message, okay, server gives me signals with two ticks. Okay, gives me two ticks. Okay, that shows that he has received the message. The server has sent the message. Okay, WhatsApp has done its job. Okay, and further acknowledgement is sent to me when when he has read the message and he has seen the message. Okay, so that is the best example of client server model. Okay, so there is nothing so complex. It's just the all the computers are connected to the server. Okay, so we'll be seeing what are the properties of this client server model. Okay, what are the characteristics of this. Now the server, the model that we have is, it's called peer-to-peer model. Okay, so what happens that in this peer-to-peer you must be able to easily relate it, that peer-to-peer model is a model in which all the devices are connected directly to each other. There is no centralized server in the middle. Okay, like in client server model, we had a server and the client would send a message to server and the server would send ahead to the receiver. But in peer-to-peer model, we don't have this. The sender directly sends the message to receiver. Now let's send this example. Now I want to call directly to Fable right now. Again, let's take the same example. I am sitting here out in Riyadh and I am calling a friend. That's okay. Let's take an example of calling. When you call someone, okay, so what exactly happens? I am calling from here, from Riyadh. I call my friend in Alaska. Okay, so what happens? The call directly goes to him, and if he picks up the call, then I'm able to talk to him. And if he doesn't do that, then it's not like later on after some time he picks up the call when I have left the call. Okay, I just hung up. When he picks up the call, I can receive the call back or something, like it's like in WhatsApp. Okay, so it's never like he just receives message of missed call if he didn't pick up the call. Okay, so in this, when I'm calling him, so there is no center or central server among us. Okay, I am calling him, I am directly sending my call to him and he's directly sending back to me. Okay, how is the call sent, that medium, and that all we'll study later in this chapter. Okay, so now it is a peer-to-peer. All the a peer is actually a node. Okay, let's name it. So anyways, now actually node is a peer. Okay, peer is like a device. Okay, especially peer-to-peer model. Okay, so it is actually a peer-to-peer model. The easiest definition, easiest understanding of it is that it is the direct connection between the devices. There is no central server between them. Okay, so here, since we discussed, for example, central server was just administrator of the faculty member of the computer lab, and you all were connected to the computer there. Okay, like in our example, in our latest example, the WhatsApp. Okay, So the manager, the WhatsApp company is a server. Okay, they have a server, and you all are connected to. I'm connected to the server, and my friend in Alaska is also connected to the server. Now, server could manage some rights. Okay, it could block some account. Okay, it could delete some number. It could, make some changes. It has administrator rights. Okay, it could make some changes to you know any of the contents. You must be having a very common issue, like when they say the the disappearing messages are on or something, like the chat is cleared, or the different updates they keep giving. Okay, your security code with, yes, that is very easy example. For example, I'm sitting in Real, your security code with your friend in Alaska has been changed. Tap to learn more. Okay, so I never asked them to do that, but they did it for maybe for some security or for whatever they did that. Okay, so they have like a kind of administrator rights over both of our accounts. Okay, over both of our security codes that they say. Okay, so but in what happens in P2P model, there is no central server, no central you know server or administrator that is connecting both of us. Okay, that is administrating both of us, the sender and the receiver. Okay, so both of us have our own rights. Okay, so that is a very the phone calls a very good example of the calling of the P2P model. Okay, so now let's see the difference between them. That's it, kind of. Okay, P2P model. Now, P2P a distributed application architecture that partitions tasks or workloads between peers. Okay. Now, for example, I have to call my friend in Alaska. Okay. So, what application do I use? Like phone that is there, the application for where you call. Okay. So, I use that application. Okay. Application that partition task. I call him and then he picks up the call and then we are connected. Okay. But what happens in client server? A distributed application structure based on resource or service providers called servers and service requesters called clients. Okay, so for example, in this the same example that we have, the service provider is the WhatsApp company, and I am the requester. I request I request the service. Okay, if this is a very good definition they have given for the client server model, a distributed application structure. You can based on resource or service provider, like resource providers, they provide us the service. Okay, called service servers and service requesters. Okay, called clients. Okay, so that's what makes up the name client server model. It's very easy to remember this. Okay, not so complex, not so complex, right? Okay, now let's move on. Each node can request for service and provide services. Okay. Now in this, any node that is connected to the internet, okay, it can ask for like calling someone else. Okay, or for example, the anybody, like all are equal. Like all nodes that are connected to each other they're equal. Okay, anybody sitting in Alaska, anybody sitting in the in Riyadh, anybody sitting in Punjab, Lahore, okay, sitting in Istanbul, okay. So they all have the equal rights, okay, equal status. Anybody can call anybody they want, okay. So that simply means anybody can request services, okay. Well, like, but corresponding to that, client request for services and a server responds to the service. Okay. Now, if the server that is there, it cannot start, asking for the, services from anybody else. Like WhatsApp does not need to ask. For example, if WhatsApp has to send a message to me, they'll directly send a message to me. They don't need a server in the middle, okay? Because they're themselves the servers, okay? So they don't request anybody for the service, okay? So client request the server for the service and server responds with the service. Okay, like I am a client, I request for sending a message, there is a service from WhatsApp to my friend in Alaska, and the server responds to me by sending the message away. Okay, now what is a decentralized network? Okay, decentralized, that there is no center between them. Like the corresponding is a centralized network, which is which is more, centralized. Like there is a central server between among them. Okay, so that that can deal with all the services that they offer. Okay, but a decentralized server, that is that they are not connected to, like they all are connected to each other, they're not connected to a central server. Okay, the centralization that is there, that's not, you must have studied in the blockchaining, okay, in the cryptocurrency, that there is no, the cryptocurrency, the concept that is there, that is actually decentralized concept. Okay, like the banks that we had, or the banks that we had, they were actually centralized networks. Like if I sent a message, if I sent my payment to someone, okay, so that bank would have, like bank would work as a central server, and then I was able to send him the cash, okay, and then bank would have the receipt of it, and like it would say will charge me something, okay. But like for example, BitTorrent you're using, or you are using some other cryptocurrency, so when you send a message, when you send, like when you transact the transaction, okay, so that directly goes to the next person, okay, then a hash is made, okay, then a new block is made, okay, in the blockchain. So there is no centralized server that is somebody who's controlling it, okay. Yes, those miners are there, okay, but they are dedicated and they are not actually controlling that. They are just maintaining it. Okay, anyways, now this is peer-to-peer reliable as there are multiple service providing nodes. Like now see, multiple service providing nodes, but anybody can provide nodes. Any node can provide service actually. Okay, मतलब I mean anybody can call, okay, and anybody can pick up the call. Okay, so for example, there are some service providers as well. Like you can connect the service providers. For example, Jazz. Okay, so they provide some services. So you can call them, and you can ask them for providing you some service. Okay, but what happens is, client depend on the server failure in the server will disturb the functioning of all clients. Like the clients that are there, okay. For example, if today WhatsApp is jammed, or WhatsApp is hacked, or WhatsApp is down, so we all clients that use WhatsApp are dependent on WhatsApp. Okay, as soon as it is down, we are not able to send out so many of our messages. Okay, so that's what they say. Client depend on the server failure in the server. Okay, will in that in the server that will disturb all the function of all clients. Like if the central server fails down, so that means the whole network has failed. The whole network has fallen down. The whole model has fallen down. Okay. Now, service requesting node does not need to wait long. Okay. But look, like if I call someone, okay, so there is no central connection between, and there is no central server between us. So that the call is soon going to reach the receiver. Okay, and he picks up the call. But what happens for this, access time for a service is higher. Like first the message has to go to the WhatsApp. Okay, like it has to first be on the server. That's how I can back up my messages. Okay, if I want to, and then the message goes to the receiver. Okay, so that may take a longer route, and then the access time for a service is higher. Although this time differs in very small, you know, like very small differences in the time. Okay, and now expensive to implement, like implementation initially, you did not talk about it. Like expensive to implement, what do they mean? For example, the case of Uber. Okay, Uber, that we have the service, the company that we have, Uber, like for where you get the rides. Okay, so they actually connect the rider to the to the to the request, the one who needs request. Okay, the one who needs service, so they actually connect both of them together. Okay, and then they are able to like connect with among themselves, and then they talk, and then whatever they need to, like they can book the ride and then talk about the affair and go for that. Okay, but what about client server? Does not require extensive hardware to set up the network. Like now peer-to-peer, the hardware example, the best example is, for example, if five computers are connected together. Okay, so each one, if you are using client server model, so each one will need a, let's see the examples, use diagram. Now in this, four computers are connected together. Each one needs a wire to connect to server, and it's connected to the whole network. But whereas in peer-to-peer model, in four connected, each one needs a wire to connect to the rest three nodes. For example, node 3 needs one wire for node 2, one wire node 1, and one wire to node 4. Okay, so that makes up a lot of mess and lots of wires. Okay, if they ask you lots of disadvantages, so you can even make up more disadvantages out of the wires, like tripping hazards. Okay, so and anybody may fall down. Okay, may trip over the wires. Okay, so these are the that's what they mean by like expensive deployment does not require extensive hardware to set up that. Whether you just need a server in the middle, okay, like surely the administrator already is there, so you just connect all of them together and the administrator in the middle, okay. Then comparatively less stable, okay, like nobody is controlling some network, nobody is administrating some network. If there's a fault, like if there's a fault in it, okay, if the computer, if the network falls down, okay, it fails. So like the nobody or like some dedicated team is not there to like manage that system. While in the client server model, we have more stable and secure. You must have seen as soon as you call someone on WhatsApp, okay, so you see end-to-end encrypted is written there, okay. So that means like you must have seen that encryption in your O levels, okay, as you see even. But the entire encrypted is like the security method that you use, okay. So more stable and secure, that they are providing you some security method, okay. So they are actually controlling it, so that makes it more stable and more secure and more and well organized it is, okay. So that is that was the client server model and the peer-to-peer model, okay.